Lesson 6-6, subtracting mixed numbers with renaming. And in this lesson, you learn to subtract mixed numbers involving renaming. And when are you ever going to use this? You'll subtract mixed numbers involving renaming when you work with stock market prices. Brenda belongs to a cycling club. The club meets and rides every weekend. Brenda rides during the week to stay in shape. On Tuesday, she rode her bike 4.5 miles. On Thursday, she rode 6 1/4 miles. How much farther did she ride on Thursday? And you know for a fact that in this lesson, you'll need to, in this example, you will need to subtract, okay, to compare the mileage. Remember the three meanings of definition we learned in the previous lessons. Okay, so we want to get 6 1/4 minus 4 1/2. Okay, so we get the LCD of 6 1/4 and 4 1/2, which is 4. If the LCD is 4, 6 1/4 does not change, and we rename 1/2 to become 4 2/4. Okay, so if you notice, okay, if think about this logically, and you have the fraction 1/4, it is physically impossible to take out 2/4 from 1/4. So what do? Let's use a model first to model this. So you have 6 1/4 right here, and you want to subtract 4 2/4. Okay? If you notice, if you only have these two fractions, it is going to be physically impossible for you to subtract 2/4 from 1/4. So what do? You notice that, well, I said that before. You cannot subtract 2/4 from 1/4. We need to rename 6 1/4 as 5 5/4. Okay, so let's do that again. 6 1/4, 4 1/2. Okay, rename 4 1/2 to become 4 2/4. Okay, and we will rename 6 1/4 to become 5 5/4. Now, if you do this, if you notice now, you can subtract 2/4 from 5/4. That becomes 3/4. 5 minus 4 equal to 1. And this is very evident using a model. Okay, so we have that 6 1/4 right here, the one we have there. Okay, so what we're going to do is this. Look at this. Okay, the 6 1/4. Okay, one of the sixes, one unit of the sixes has been uh, divided into fourths. It is still 6 1/4, but now one of the sixes, okay, has been divided into fourths, and that's the reason why this becomes 5/4. Okay, and if you subtract 4 2/4 from there, it is very evident how you will get the product of, okay, 1 3/4. Okay, because 5 minus 4, 5 minus 2, I'm sorry, will give you 3/4. Okay, and 5 minus 4 will give you 1 whole unit. So Brenda rode 1 3/4 miles farther on Thursday. Okay, and as shown above, it is sometimes necessary to rename the fraction of a mixed number as an improper fraction in order to subtract. Okay, let's take a look at example 1. Find 4 minus 2 1/3. Okay, so 4 minus 2 1/3. Again, okay, you cannot subtract 2/3 out of nothing. So what do? You need to rename 3, and you need to borrow 1 from 4 and rename it using a denominator of 3. So basically what you want to do is you get your 4, okay, and you borrow 1 from 4, this becomes a 3, and the one that you borrowed from 4, you will add it, and since this is 2/3, denominator of 3, you will do 3/3. So you'll rename 4 to become 3/3. If you notice, 3 plus 3/3 is still 4. You're just renaming it. Okay, so this becomes now 3/3, 3 and 3/3 minus 2 1/3. Now you can subtract 2/3 from 3/3. That becomes 1/3, and subtract 3 minus 1 will give you 2 1/3. So 4 minus 2 1/3 will be equal to 2 1/3. Okay, let's take a look at example number 2. Find 17 1/4 minus 3 and 5/8. Let's go back to what we've been doing. Let's estimate round 17 and 1/4 to be 17, round 3 and 5/8 to be 4. Our estimate answer should be close to 13. Okay, step number 1, let's do this. 7 1/4 minus 3/5 written vertically. Okay, if you also know, if you notice in this particular problem, you don't have like denominators, so that means you go back to your LCD. Okay, so the LCD of 4 and 8 would be 8, so we rename 1/4 to be 2/8. Okay, and we keep negative 3/5, because the LCD of 2/8 and 5/8 is 8, or the LCM of 4 and 8 is 8. So that's step number 1. Okay, after going through step number 1, if you notice 5/8 is greater than 2/8, it is physically impossible for you to subtract the fraction 5/8 from 2/8. So what do? You borrow 1 from 17. Okay, so what happens is you now have 17 and 2/8 minus 3/8, and you borrow 1 from 17. This becomes 16 right here. Okay, and the 16, the one that you borrowed from 17, you'll add to 2/8, which is, since the denominator is 8, it becomes 8/8. You're adding 8/8. That's the one that you borrowed from 17. Okay, so you end up with 16 and 8/10, because 2 plus 8 will give you 10. Keep the denominator the same. Okay, now if we look at this now, we now have 5/8 can be physically subtracted from 10/8. So we simply subtract 10 minus 5 will give you 4. Okay, and 16 minus 3 will give you 3. So you end up with 13 and 5/8. Sorry, 16 minus 3 is not 3 but 13. Okay, so the difference between the greatest, where is it? It's there it is. 17 and 1/4 minus 3 and 5/8 is equal to 13 and 5/8. Okay, and let's take a look at example number 3. Life science. A male Californian sea lion grows to be between 6.5 feet and 8.5 feet long. Find the difference between the greatest and the least lengths. So what do we need to do here? We need to subtract 8 minus 6 and 1/2. The first thing we need to do is estimate 8 minus 7, because 6 and 1/2 rounds to 7. So our answer should be close to 1. By the way, secret word before we continue this would be Adrian Peterson. Adrian Peterson, a secret name. Thank you. All right, let's continue. So 8 minus 6 and 1/2. Okay, so 8 minus 6 and 1/2. You know that you cannot physically subtract 1/2 from nothing right here. So what do you need to do? You need to borrow 1 from 8. Okay, and this becomes 7 and 2/2. Again, why did we use 2/2? Because we have the denominator of 2 in 1/2. So we use that, so it's easier for us to subtract like fractions. After renaming that, we simply keep negative 6, 6 and 1/2, and we subtract 2 minus 1, 2/2 minus 1/2 will give us 1 and 1/2, and 7 minus 6 will give us 1. So you have 1 and 1/2. So the difference between the greatest and the least lengths is 1 and 1/2 feet. And that is the end of our lesson. Thank you for watching.